Welcome to the deep dive. Today, we're looking at something pretty specialized, high-performance video connectivity. Specifically, the DVIGear DVI-2880-AOC Active Optical Cables. They're part of the Hyperlight series.
Right.
And when you see a single cable, the 80-meter version is listed at over $900, you immediately have to ask,
What is this thing doing?
exactly, what problem is it solving? So our mission today is to really unpack the engineering here and figure out why this cable is built for, mission-critical applications.
And what's so fascinating right off the bat is that it isn't pure fiber optic. It's actually a deliberate hybrid design.
Okay, a hybrid.
Yeah, to get that high-speed video signal over these huge distances, it uses 4 glass optical fibers, the GOF.
Those are the fast lanes.
Those are the fast lanes, exactly.
Yeah.
But, and this is the key part, it also keeps 6 traditional copper wire for things like power and low-speed data.
And that mix is what allows it to hit these really high-end standards, right?
That's it. You're looking at DisplayPort 1.4 HBR3.
High bitrate 3.
And that standard is what unlocks this massive bandwidth. We are talking about an aggregate data rate of up to 32.4 GBps.
Which is, what, 8.1 gigs per lane?
Per lane, yeah. So that brings up the big question, right? What does all that bandwidth actually get you in the real world over distance?
And this is where it gets really interesting. Because those main signals are light, traveling optically, these cables can extend these huge resolutions up to 328 feet.
100 meters.
100 meters, which means you can actually get 8K resolution at 30 hertz.
7680 by 4320.
Or, super smooth 4K at 120 hertz. And another thing, it has this ultra-low power design. It draws less than half a watt from the source.
So no external power supply.
None at all.
Now, we connect this to the bigger picture. Using optical transmission provides some really huge benefits, especially in professional environments.
You mean beyond just the speed and distance?
Oh, absolutely. Because the video signal is just light, the cables are basically immune to environmental noise.
Right. So no RFI or EMI interference.
Exactly. And that provides this incredibly low RF-IME profile, which is, it's mandatory for sensitive applications. Think medical, military, anywhere signal security is paramount.
So on the practical side, how do you even install something like this? Pulling fiber through conduit sounds like a nightmare.
It can be, but they've thought about that. The cables themselves are compact, they're lightweight, and they're plenum rated.
UL-CMP-OF, so you can run them in air handling spaces.
Yep, above the ceiling tiles. And they have a pretty flexible minimum bend radius, around 35 millimeters.
Okay, that's tight.
And here's the clever part for the installers. The Koblenz have these tiny mini DisplayPort connectors. They're less than 8 by 11 millimeters.
So they're easy to pull through the conduit.
Much easier. Then once it's pulled, you just attach the included full-size DisplayPort docking connectors. They even have a little locking pin for security.
That's smart. And what about reliability? For that price, you expect it to last.
You do. And the professional metric they use, the MTBF, or mean time between failures, is rated at over 150,000 hours. So for you, the learner, that means this thing is designed to run for years and years without a single issue.
So when you put it all together, what this really is a flagship solution. It gets you the resolution and the distance by blending the best of both worlds.
Right. The optical and the copper, all in one package that's secure, robust, and surprisingly easy to work with.
So for you listening, this really highlights a critical point in high-end AV, doesn't it? When you need that flawless image quality, plus extreme distance, plus total dependability.
Yeah, that move from just copper to a hybrid fiber solution like this becomes pretty much mandatory. There's no other way to do it.
Okay, so let's end with a final thought on that. Think about that AUX channel, one of those little copper wires.
The low-speed one.
The really low-speed one. It only operates at 1 mBp. It's tiny. But it handles all the crucial bidirectional communication, like EDID and link training.
The handshake, yeah.
Yeah.
Where the source and the screen agree on what to display.
Exactly. So here's the thought to mull over. Just how vital is that tiny, simple, low-speed data path for making sure the massive 32.4 Gbps video stream it controls actually works flawlessly?